Okay, we're going to continue our discussion of analytic geometry, and we're going to continue with our topic of conic sections. So this time we have two cones again. We're going to slice them with a plane, and in this case we're going to form right here this shape, an ellipse. Okay, so it's elliptical. All right, it's the planets move in an elliptical orbit, if you will. So we're going to be talking about an ellipse, and that's the shape of the graph that we're going to be working with. So let's go ahead and take a look at some examples of coming up with some equations for ellipses. But it's important to note that the graph of an ellipse is not the graph of a function, and that right there I think is one of the most crucial things, is we can graph them, but it's not a function. And why is that? Because it fails the vertical line test, if you will. If you have a graph, if you recall the vertical line test, if it's a function, a vertical line can only touch a graph at one point. Otherwise, it is not a function. Okay, so this relation here, not a function. All right, so let's go ahead and dive in and try to come up with these equations for an ellipse. So first thing to note is that there are two types of ellipses. All right, one is a horizontally oriented and one is a vertically oriented. So this one is the horizontal and this one right here is the vertical. All right, so there's a difference in how much it opens. So if this a value is greater, all right, if a is greater, then it's going to be facing, horizontally left, right. If in this case, and if you look at it, I mean, I know it says A, but it all depends. If A is greater than B or B is greater than A, all right, if you will, that will tell you which way that it's oriented. And I know that it's kind of hard to see in this picture, and I don't know why it got chopped up, but the vertices, all of these weird little squiggly things should say plus and minus. Plus and minus. Okay, so that didn't output right for some reason, but that's what it means. It should have said plus and minus. So it's going to have a set of vertices, a set of endpoints. It's going to have something called a minor axis and a major axis. So the minor axis, if you will, is just the smaller axis where it's narrower. And the major axis, of course, where it is wider. All right, and let's go ahead and take a look. And I think once we figure it out, we'll start to understand this concept. But what I'm going to do for problem number 1 anyway, I'm going to make a rough sketch of what this ellipse looks like. So it says it has x-intercepts of plus and minus 6, 0. So let's just pretend right here this is -6. And this is +6, maybe not necessarily equidistant. So let me adjust that. All right, maybe here and here. That maybe looks a little bit better. And then y-intercepts of plus and minus 3. So let's just say that's here and that's here. So -3 and +3. And so we'd have an ellipse that looks like this because it'd have to touch point to point. Okay, we'd have to connect it like this. All right, so in this case, the measure here is our value for A, and the measure either here or right below it is the value for B. All right, so in this case, A is 6 and B is 3 because that's the length of that little part of the graph, how many units long it is. So to come up with this simple equation, x squared over a squared plus y squared over b squared equals 1. All right, and we're going to say that x squared will be over 6 squared and y squared over 3 squared, and that should equal 1. Okay, and when we simplify this, we get something like this: x squared over 36 plus y squared over 9. And that's a funky looking plus sign there. And that should equal 1. Okay, so this right here, the equation for the first ellipse. And we know that we're following this form right here, again, because this value here, a is 6, was bigger than the value for b is 3. So a is greater than b in this instance. And we knew we needed to follow this setup right there. Okay, so let's go ahead and take a look at the next example and see what we get. So give me a second and we'll come right back. Okay, in this second example, we are only given the x-intercepts and we're missing the y-intercepts, but that's okay because we are actually also given the foci. So the foci are the two focal points, okay? It's just plural for focus, foci, all right? So let's see what we're dealing with here. If the focus is C0, in this case C0, we know that this ellipse is going to be of this variety, because look at the focus formula, because over here it would be 0C. So it's not oriented vertically, it's oriented horizontally. So given that we know the x-intercept already, we know that this is the value A, and all we're missing is the value B. Okay, but that's not a big deal, because if you look here, it's just a case of the Pythagorean theorem, right? It is just a case of the Pythagorean theorem, and you'll be able to find B very quickly and simply. All right, so let's write down the formula for the foci. All right, the formula is c squared equals a squared minus b squared. And it's actually not the Pythagorean theorem now that I think about it. It looks like it, but taking a step back, it's actually not the Pythagorean theorem, but it looks similar. Okay, so we're going to take 4 square root of 2, because that's the c value. We're going to square it. We're going to say 9 square minus b square. And what do we get? All right, we get something like 16 times 2 equals 81 minus b squared. 16 times 2 is 32 equal to 81. And we're going to subtract, equal to 81 minus b squared rather. Subtract 81 from both sides, and what do we get? We get negative 49 equals negative b squared. And then we divide both sides by negative 1, of course. So b squared equals 49, and in this case, b will equal 7, because all you have to do is take the square root. So we've got our a, we've got our b, and now we're ready to set up our equation for the ellipse. X squared plus y squared on the bottom. A goes first. A was 9 square, and b goes second, 7 square, and that should equal 1. So it's a no-brainer from here. X squared over 81 plus y squared over 49, and that equals 1. All right. So this is the second equation. A little more work, but we're just using the formulas that we were given. Okay, but if this video was helpful, as always, be sure to like and subscribe.